Hello, everyone, and welcome to our second and final video for the second to last week, of class for us with advanced exercise physiology at Concordia, kinesiology 416. And we're going to talk about the first half of chapter 9 today on performance with environmental stressors, specifically about hot and cold environments. It takes up a majority of the chapter, interestingly enough. So I'm going to, even though this might be a shorter lecture video than is going to be the video for Monday of next week, which will be covering the second half of this chapter and a little bit of chapter 10. I want to spend at least a reasonable amount of time talking about hot and cold environments and why there are drastic changes in performance and drastic differences in demand by the body to perform. So with that said, as we go into this final week plus, hope things are going well for you, of course, as always. I don't want to neglect to say that. Talking about performance, I thought it was interesting. The book noted that performance is one of the most important aspects of exercise physiology, and I'm going to jump on that a little bit more and say performance is not just an important aspect of exercise physiology; it's the most important aspect. Now, the textbook, we did take it into context, I think. Is referring to more in terms of actual physical performance from like an athletic or fitness type endeavor. When we talk about performance as a whole, we're talking about any aspect of physical capability and performance, which will affect mental performance, will affect all sorts of other factors beyond just your capacity to perform physical work. And so in that respect, performance is the key. That's the end result. And if performance is at an optimal level, it's hard to argue with what's going on at the moment being necessarily a negative thing if you're doing something better than you've ever done before. And obviously, if it means you're enduring pain or something's going wrong, and as you're doing it, that's a different issue. That being said, performance is the key. And talking about thermal regulation, a normal body temperature, as notes right here, is basically 37 degrees Celsius or 98.6 degrees Fahrenheit. The hypothalamus regulates this. And now anatomy is 98.6. My base temperature is actually high 97. It's actually my base temperature is a little bit cooler, which is interesting, right? Some would suggest that would mean that I would be more susceptible to cold environments when I'm actually much more susceptible to hot environments. That being said, it's just interesting to note variances in people. That's the average. Not everybody's the exact same temperature for base temperature. But temperature limits for living cells are basically 0 degrees Celsius. They should have 0 degrees. I don't know why it says OC degree. Well, 0 Celsius degrees, I guess is what I was trying to say there. 32 degrees Fahrenheit, what we typically use Fahrenheit in the US, right? Western culture. Ice crystals form at that temperature. They begin to form on cells, which is not a good thing, right? That said, up to about 45 degrees Celsius or 113 degrees Fahrenheit, whereby at that point intracellular proteins start to unravel. And having an intracellular protein unraveling, it doesn't take a rocket scientist to figure out that's not a good thing. Luckily, even though the external temperature in some situations might be more than 113, just like the external temperature to our body might be below 32 degrees Fahrenheit, it doesn't mean that our body's going to turn to solid ice or that we're going to burn up, right? However, technically, when exposure is at those temperatures for lengthy periods of time, that will happen. It will be slow, but it will happen. That being said, in order to try to maintain those temperature tolerances or able to tolerate outside temperatures, your body will do its best, of course, and it's more tolerable when temperatures are basically between like 95. When temperatures outside, get way up there in that 95 to 105 and are trying to perform athletically, those are dangerous areas. Those are times where we're going to be considering whether it's really necessary to be training. And we'll talk more about bulb temperature in a minute here, as well as generally speaking what that temperature would really be when we really look at aspects of humidity, aspects of basically when albedo with the sun basically on like a black backdrop, or what, depending wherever you're training outside and it's on a black pavement versus a different surface, it's very different for the heat too. And so you're talking about the humidity, the actual temperature, and as well as the albedo plays a big role. That being said, we'll come back to that. 4 primary ways which we gain heat production and transfer body heat. There's conduction, which is actually technically touch, right? Heat's delivered via the arterial blood, then conduction to subcutaneous tissue, and heat or cold by objects touching the skin will by conduction can change your temperature at the skin layer. Obviously, if it's left there a significant amount of time, it's going to radiate. These are all forms of radiation. I mean, even that can create some radiation as well, not just from the physical conduction, which we'll get to radiation in a second too, but we'll get more and more cold in that area depending on the size of the object, how cold it is, can play a greater role in playing in affecting your limb or wherever that contact is being made, and potentially more of your body, depending on how much of the surface area of your body it's in contact with, which is why wind or water in particular plays a huge role in conductivity of changing body temperature. Convection is motion of a gas or liquid across an object. Basically, with the greater the movement, the greater the rate of heat exchange, whether it's body warming or cooling. So certainly if a cold air is going over you at a faster speed and a greater level of heat at a basically faster speed over the top of you, so it's maybe you have something blowing hot air at you, you're going to be warming a lot faster, right? Not terribly hard to figure that out. That's convection is occurring at a faster rate. Likewise, would be the same for cold air and add a cold wind to it. You can actually decrease heat a lot faster. Radiation, basically everything radiates to some extent. Everything radiates basically heat or cold to some extent. At room temperature, the naked body loses about 60% of heat by radiation. Okay, that's a lot. Infrared rays are a type of electromagnetic wave. We all have to talk about sun radiation, right? Evaporation is the only non-dry form of heat exchange, okay? Only wet form of heat exchange, essentially. And accounts for 80% of the total heat loss during activity and 10 to 20% of our heat loss at rest. At rest, you may not think you're sweating necessarily, but even at rest, there's going to be some heat loss. And so that has to be understood. When just sitting still, you expect to see a bit of a drop in body temperature, definitely a little drop in terms of heat loss, which is why, like a lot of times when I'm teaching a class and there people are sitting in the class, it doesn't affect me much. I'm the one moving around and talking. I'm at least 10, 20% higher from a standpoint of less likelihood of losing heat. So I'm not going to be the one getting cold, whereas someone else in the classroom might be getting cold because they're sitting still, right? That being said, with humidity, evaporation, which is the goal, not the goal, but one of the benefits of when you sweat and it evaporates, it actually helps with the cooling process. When it's humid, hot and humid, so you're sweating like crazy, but it's not just leaving your skin and evaporating. It's just staying there. It's so humid, right? So much moisture in the air. Evaporation is not happening at the rate you'd want it to be to help cool you. Sweating is basically the only method of cooling when the environmental temperature exceeds the skin temperature. Okay. Now, going with exercise in hot and cold environments, with repeated heat or humidity exposure over a few days. And the book will mention acclimation versus acclimatization, and the textbook, the Kenny Costal textbook you use for ex-phys versus another Wilmore and Costal book I use for different ex-phys class for the MCA program for the coaching math master's program, all at Concordia, 3 different textbooks, all refer differently to the phrases of acclimation and acclimatization. And then I looked up research on it, and you get different sources talking about acclimation versus acclimatization differently. Some refer to acclimation as what happens in a few days. Acclimatization is what happens in a few weeks or months or years. I should say days and weeks. Some books refer to that as acclimation, and months or years acclimatization, whereas the textbook, and I've seen other sources as well, refer to acclimation as being one aspect of adjusting to basically hot or cold or the environmental factors. And they typically refer to more the controlled type setting like an indoor environment or a lab, whereas acclimatization is responding to multiple factors. Either way, I'm not going to nitpick you on the difference in definition between those two terms because there's so much differentiation in them. Again, welcome to so much in terms of information that's out there. There is oftentimes a disagreement in the actual term to be used, and less concerning is the term itself. More concerning is what we do with that information. What are we talking about? Are we consistent with understanding our message? That's more important than which word we use, really. That being said, a few days, 7 to 14 days, acclimating or acclimatizing, as little as 3 days. Someone can actually adjust in some cases as fast as 3 days to an extreme hot or cold, particularly more toward the heat in most situations. There's an increase in kidney sodium retention and plasma proteins, which results in increased plasma volume up to 30% in a few days. Now, that increase in plasma volume is what's helping you cope with the change in temperature, the change in the environment, to be able to proceed at normal output levels without causing extreme fatigue, right? And that's why we always say to drop your level of performance the first day in a new environment that's hotter or colder, substantially so than normal, and then slowly ramp up, if at all possible, to do so. That said, then of course performance will normalize and adjust as fast as 3 days, typically 7 to 14 days. That does require repeated exposure over every one of those days. You don't have days between when doing nothing. It's going to take longer to acclimate or acclimatize to the environment there. That said, also during that time of acclimation or acclimatization, there's adjustments of VO2 max. Your body's adjusting from a standpoint of higher requirement for oxygen utilization, obviously, because you're under more stress, particularly true for when it's more cold, plays a role. That being said, that's arguable depending upon the athlete. It's arguable depending upon the environment, how significant and extreme it is versus the norm for the athlete. There's a lot of variables here, but there is that potential. Venous return can be sometimes a problem, which means blood pooling and venous pooling, whereby we're more likely to induce more fatigue, stiffness, soreness potentially from training. So we want to make sure we understand that and actually more gradually regress a little bit, I should say, with the training until we bring it back up to normal over the course of a few days or a couple weeks. And blood lactate levels are also going to be higher, understandably, because you're working harder to maintain body temperature, whether because it's too hot or too cold. So consequently, the skeletal muscle has to be working harder to do the same work and to get the same blood supply. And oxygen nutrients needed. So that's why there's such a challenge and a difference in hot and cold environments. That being said, function of the heat, aerobic versus anaerobic. Again, there's increased VO2 at similar intensity, but regardless of performance goal, the brain is going to send signals to stop exercise, usually between but essentially 104 to almost 106 degrees Fahrenheit for us. And that's different with sprinting versus prolonged performance. We're talking about someone trying to do in a marathon, 104, 105 degrees heat. Good luck. That's going to be difficult to do. Doesn't mean the person will pass out. It's a good chance of it, though. Exerting any reasonably high level at that heat, there's some serious performance challenges there. No question about it. Could be an increased need for nutrients in terms of carbohydrate intake, not just water intake, which we'll talk about in a second here. Sprinting is going to be much more helped a little bit by increases in heat. From the standpoint of fatigue is less of an issue in very, very short bouts of exercise. And because of the heat, there may be some greater elasticity in a very short period of time. And so consequently be more warm easily. You got to be careful about overdoing it. In hot environments, we want to make sure the warm-ups and the cool-downs are very short, 3 to 5 minutes-ish, both ends of that, whereas cold environments could be 15, 20, 25 minutes and beyond, all depending upon the athlete and the situation for lengthening the warm-up and the cool-down to adjust for the temperature changes. There's no question about it, particularly in the heat, but also true in the cold. There's increased neuron and fiber involvement whenever you're trying to adjust to differences in temperature. Reduced blood lactate removal. It's harder for your body to be able to expend the energy necessary to be able to reduce blood lactate because of poor lesser circulation to the skeletal muscles, because you're either trying to warm the internal organs when it's cold or trying to warm the skin, cool the skin, when it's warm. And of course, increased sympathetic nervous system activity is going to cause increased more epinephrine and going to increase the heart rate. And when you're increasing the heart rate, it's been speculated too that the increase in heart rate, because of what's going on internally, that causes a decrease in stroke volume. So in the situation where you're adjusting to hot heat in particular, but to some extent an external environment that's new to you, cold or hot, you're going to have essentially higher epinephrine, you're going to have a higher heart rate, and that's going to cause a reduced stroke volume, as opposed to you've lost stroke volume causing an increased heart rate. Okay, which was normally the difference in training, right? If you stop training, you lose stroke volume, so your heart rate goes up relative to similar levels of performance. Whereas if you're training properly, you're increasing the stroke volume, so your heart rate's going to lower at the same level of activity over time. But during times of trying to acclimate or acclimatize to hot or cold, you're going to see the heart rate affecting the stroke volume. That's both the other way around. body fluid imbalance and sweating. Elevated blood temperature causes the hypothalamus, basically the posterior anterior pituitary and the adrenal axis with the hypothalamus, cause the transient impulses that are triggered by acetylcholine through sympathetic nerve fibers to millions of eccrine glands, okay, and those sweat glands, right? And the loss of electrolytes in the water and the sweat creates increased loss of plasma volume. So although your body's trying to increase plasma volume to adjust to stress, you're going to be losing plasma volume if you're sweating a great deal. So consequently, the whole idea is you adjust so you don't need to sweat as much when you become used to that particular temperature. So consequently, you have an increased plasma volume as opposed to decrease. And of course, when you have a decrease or loss of plasma volume, that's going to lead to decreased venous return. So again, we're talking about venous pooling issues, subsequently reduced stroke volume and cardiac output. And that triggers the release of aldosterone, which is basically from the adrenal cortex, limits and maintains your appropriate sodium concentrations from kidneys into the blood, so it changes your aldosterone secretions, as well as antidiuretic hormone, ADH, from the posterior pituitary, also called vasopressin or arginine vasopressin, and it stimulates water reabsorption back into the kidneys. Okay? Health risks training in the heat. Heat cramps are fairly common. They're severe and painful cramping of large muscles typically due to sodium loss and dehydration from high rates of sweating. What's interesting is you'll see some sources will say dehydration has nothing to do with cramping. Like, well, it's kind of hard to imagine that dehydration would not play some role in because of water helping being the predominant nutrient that relates to or the total blood volume essentially. Consequently, we don't have enough water, we're going to have restricted blood flow, and that's going to affect all sorts of possible things, including possibility of heat cramps, which that being said, with high rates of sweating and water loss, dehydration, and really what's also believed to be the case is we have a decreased sensitivity of the Golgi tendon organs at muscle tendon junction, as well as muscle spindles being more hyperactive, more active. So you can get these guys engaging more and these guys engaging less. So you get this hyperactivity of the muscle and nothing to try and get it to relax, and then you get cramping, okay, which seems to be a fairly recognized possibility for why heat cramps occur as well. Bananas aren't helpful. Potassium is not going to help the issue. Some people refer to that, right? Taking a bunch of salt in right now, it's possible, right? But you also got to be careful things like that, because you don't necessarily need to be adding salt when someone's not low in salt. That actually can create problems in the immediacy of the environment. A little bit of salt's not going to hurt anybody from a general perspective, but you got to be careful when you start talking about taking salt tablets, things like that. Make sure someone really knows what they're doing before you do something like that. Heat exhaustion is when you get extreme fatigue, dizziness, nausea, profuse sweating, ceasing to basically cease exercise altogether, drink fluids in a cool place with the feet elevated. I believe I got cut off here with my heat stroke a little bit, but heat stroke is basically when temperature is above 104. And it's not so much extreme fatigue, you're going to cease performing, going to pass out, either really close to it, stumbling around, or actually passing out. And that happens, typically speaking, in some sports when there are a lot of athletes relative to the number of coaches, or they're going at a really high rate and not paying enough attention. To me, it's always a matter of not paying enough attention to athletes, letting them know it's okay to say you're not doing well. Too much is thought of, you got to be tough. Well, you do need to be tough, but you also need to tell me if you think you're going to physically pass out. But unfortunately, it is what it is in some situations whereby some athletes feel as though if they bring up that concern, then all of a sudden they're looked upon as lesser of an athlete, and consequently they're going to be looked over when it comes time for their position and their playing time. I think that's wrong, but I get it. When you're in those situations, it's a different environment sometimes. Have to try to avoid it is hopefully coaches taking into account heart rate and RPE every single set, let alone measuring performance, rather than just going endless numbers of burpees or endless numbers of suicide runs back and forth across the field or across the court or wherever you are. Same thing as in any sport. Everybody loves that particular form of conditioning. Go, go, go for 20, 30 seconds-ish, maybe 40 seconds, take a break, and it's a very short break and then go again, which really goes against the whole idea of everything we talk about glycolytically, right? Your break is too short, you're breaking like it's aerobic work, and yet you're training like it's anaerobic glycolytic type work. What do you want, coach? A lot of coaches do that, and that's a risk because they don't understand the differences in energy systems, muscle fiber types, let alone the real benefit we're trying to get here. The most athletic people will keep going, and those who are not will potentially be at risk for heat exhaustion or heat stroke. Okay? And heat stroke often is the case where sweating has ceased. Sweating itself is not necessarily the best indicator by itself for heat stroke versus heat exhaustion. Heat exhaustion, or heat stroke, excuse me, as a 911 call. It's going to be obvious. When someone's incoherent or unresponsive, or in general, when you just don't know what to do, that's a 911 call, okay? Preventing hypothermia, avoiding exertion if the wet bulb globe temperature exceeds 82 degrees Fahrenheit, and that's measuring three different things as wet bulb globe temperature. Again, measuring the actual temperature, measuring basically the humidity, essentially the wet temperature, as well as measuring again the albedo, like the sun actually with a black object essentially to measure how intense that heat is from radiation from the sun. Okay. Frequent hydration, specifically, there are different numbers in this regard. If you have slightly different numbers from this from different sources, it's not a concern. These aren't exact, but these are good numbers. 16 to 32 ounces every 2 hours, basically for 2 hours leading up to, I should say, the training session. 1 hour again, another 16 to 32 ounces before the training session, and 30 minutes before exercise, another 16 to 32 ounces before the training session in situations where it's going to be extremely hot or extremely cold. Granted, depending on the person who doesn't normally drink a lot of water, that's going to be too much. So they got to drink at least more than they're used to. And generally speaking, for optimal performance, those are the numbers that are pretty solid. There's no question about it. When you first start doing this, you're adjusting to it. All of a sudden, you're peeing like crazy really regularly. But I will tell you flat out from an older athletic perspective, and I haven't played tennis for a few years now, but not more than about 5, 6, 7 years ago, I was still playing tennis like once a week with a friend of mine, playing at a reasonably high level, at least for a 40-plus-year-old, I would say, and we played pretty intensely for an hour or two. And the simple difference on the days when I would actually do this, drink a pint or 2 pints, or basically a half a liter to a liter of water 2 hours before, hour before, and 30 minutes before, when I did that, fatigue was never an issue. Whereby if I didn't do that, it was a whole different ball game. I'd have days where I didn't get much sleep and didn't get enough nutrients in my body like I should, but the water saved me in my performance. It plays a huge role. You may have heard before that water loss of as little as 1 to 2% below your normal levels of water intake and water in your body, as far as a water percentage of your body, if it's down by 1 to 2%, could dramatically reduce performance by 10, 15, 20% or more. Pretty crazy. That's why it's so important. And then during activity, so this is pre-activity, 2 hours, 1 hour, and 30 minutes before. Then during activity, I should say both those things there, it's 6 to 8 ounces every 10 to 15 minutes for 60 minutes or less exertion. And I've seen some sources say 5 to 10 ounces, 4 to 12 ounces. There's some variance there. That's all right, but these are the best numbers I've seen for giving a good basic range. And then if someone's engaging in activity that's going to be hour plus, the expectation is an hour plus, right on an hour of really intense stuff or beyond an hour of moderately intense to intense work. If it's low intensity, this is probably not a big deal. It's still water. But for the most part, anything moderately, highly intense for that lengthy period of time is a carbohydrate beverage, something that's basically 6 to 8% carb to water solution, which is Gatorade. Gatorade nails it. Every 15, 20 minutes during exercise. Not as often as you would with the water, but you're getting the same amount of total fluid intake. This time it's carb as well as water, right? In order to help keep up at a reasonable level of carbohydrate in the system for helping with energy because of loss of glycogen. Basically, after about 60, 90 minutes of really intense exercise, it can start to become a problem for most people, let alone testosterone declining around an hour of intense exercise. Acclimation to heat. The goal of decreased core temperature and heart rate is the ideal, right? With gradual increase in activity. We always talk about that same general basic day one kind of thing. Day one, you're a new athlete or new to training ever, haven't trained in a long time, or new environment. It's much hotter than normal, 15, 20 degrees hotter than you're used to, or colder than you're used to. Some dramatic change. Dropping the intensity down substantially to what's essentially moderate intensity, the low end of moderate intensity for the day. See how athletes do and adjust over a period of a few days to normal activity. Within 7 to 14 days is the general recommendation. Could be as little as 3, right? Blood levels return to normal within days of reacclimation to normal temperatures, however. So understand that you're going to adjust again the opposite way within a few days, back to normal again. So we don't maintain those benefits as forever, right? For lengthy periods. You've only been doing it for a few days. That will also hold true with altitude type training, which we'll come to talking more about for Monday of next week. Acclimation to the cold, there's about as much as a 5 to 6% VO2 max loss for every degree Celsius change. Basically, every couple degrees Fahrenheit-ish, we're talking about a significant drop on VO2 max from what you're used to. Okay. That being said, to be really clear, cold temperatures, athletes like marathoners and ultra endurance runners actually proceed to perform the best in the low 50s Fahrenheit wise, low 50s. From a general fitness perspective, just going to do a little moderate to moderately intense workout. It's probably best at the temperatures in the 60s, the mid 60s. If it's too warm, if it's warm in the beginning, it's going to be too hot pretty quick as soon as things start to get intense. It should be a little too cool when you start just about anything, just a little bit. Like it's a little bit cool right now, right, before you kind of start up. That's the ideal if you're going to be ramping up to a significant level of intensity. If we're talking about ideal environments for increasing intensity over a period of time. Okay. And of course, the larger the body size, the larger the opportunity for a loss of heat. Certainly creates more heat to some extent, but more skin surface area. There's more issues with heat loss as well. Larger individuals have a smaller surface area to mass ratio. I'm sorry, from a standpoint of the opposite, excuse me. They will actually be more likely to retain their heat as actually smaller bodies, whereby they have more issues with hypothermia. And fat, of course, larger body mass in general, is going to impede heat transfer from deep tissue to skin layer, helping conserve heat. So people have higher fat content, generally speaking, do better when it's colder than others, right, for that reason. Of course, then you also have to play a role with take a look at genetics and what someone's acclimated to in general, as well as their metabolic rate. I always love cooler environments. I thrive in cooler and colder environments, not extreme cold, but when it gets a little bit too warm, it gets already in the mid to high 80s, I'm already not liking it. Performance for me tends to be a little bit off. I'd much prefer it to be more like 60s if at all possible. That being said, everybody's different in that regard, aren't they? The wind chill is the air movement with increased convective heat loss. A lot of times we'll talk about when it feels like outside. You'll see a little number when you look online and look at the temperature, and then it said it feels like this. That's a highly subjective thing, depending upon someone's metabolism, their genetics, their body size, their body fat, all those things, right? What they're currently doing right now, the amount of clothes they're wearing. Obviously, if it's going to be hotter out, then we already prepare by not having too much clothing on in the beginning, with the possibility of even being able to take something off, and if need be, but we don't want to be starting too hot, right? Because we're going to get even hotter. We're going to be starting cool, if at all possible, because it's going to get hotter, right? And that being said too, and the opposite for cold, we want to have a lot of layers that when it's colder and actually be able to take layers off as we get warmer. It's always a good way to adjust as well. But cold water, water is thermal conductivity. Your textbook said 20 times. I've seen other sources say as much as 26 times greater than air. So when you're in the pool, we got a couple of you that are water polo players or swimmers, and there's no question about it. Metabolically wise, during the time you're in the water, you're working harder than anybody else is because you're trying to adjust to the temperature of the water. You're fighting against the water itself. And there's nothing worse than if you're spending a lot of time in the water and you're not moving, it'll sneak up on you. Next thing you know, it is cold. As a matter of fact, there were some, I think it was Marines or Navy SEALs a few years ago who were in Louisiana doing some training, and they all died because the water temperature was about 58, 57, not terribly cold, but not warm, and they basically got hypothermic and they died, the whole group, okay, because they were left to fend for themselves, expecting to be able to adjust to cold temperatures. Well, there have to be some adjustments made for the reality. There has to be options somehow. Maybe in real life there may not be an option, but if there's not an option, then they're dying in training. So that was really unfortunate, obviously. The ideal way to take temperature is rectal temperature. Clearly not always the most ideal to be able to take rectal temperature, but that's the most accurate, right? And just like taking body fat in different ways, other body fat methods, some versus others, are more accurate, no question about it. Some are far more accurate, but the more important thing is, can you get a consistent temperature reading that's so that you actually can tell when there's a change in temperature, more importantly than whether it's perfectly accurate like rectal temperature is certainly going to be. That said, treatment of hypothermia or frostbite, the hypothalamus essentially begins to lose control when the internal temperature, your internal temperature, right? Normal 98.6, but really could be a little above that or a little below that by roughly, it could be up to about a degree of the direction, potentially for some people, usually a little less than a degree either way. But below 94, and then of course fully lost below 85, you'd be lucky to survive if internal temperature gets that low, okay, for any period of time. And of course that slows the metabolic reactions and causes lethargy, drowsiness, and possibly a coma. That's one of the so unfortunate realities with the cold. You just kind of slowly start to fade out if you're exposed to extreme cold for too long of a period of time. Body gets worn down trying to deal with it, right? That said, we'll talk about altitude training, ergogenic aids, and a few other possibilities. More thank you, no thank you, Amazon. As my Echo Dot tries to talk to me, somehow I must have said something that's got her excited. I don't know if you can even hear that at all, but she's talking to me. That being said, so final thoughts then, you have we should now already have an email to you with your person who's going to be reviewing your paper, and a second email noting that you're going to, Alexa, stop. I don't know what I'm saying, it's getting her going. But you will also get one telling you who you're going to review and who's reviewing you. And you're, of course, going to submit your paper back to that same email, and then you're going to review the one that you're supposed to review, and you're going to, that review that you made, you're going to submit it via Blackboard in the rough draft notation there. You don't have to do it until Wednesday, okay? Preferably before, of course, for your sake, so you can get through it faster. I expect it to take you 30 to 45 minutes or so to review that paper, to read through it once, and this is in the email as well. And then read through it again the second time, looking more for grammatical errors, content, whatnot, and the third time more for APA formatting. I don't care what order you do it in. That's just my suggestion for doing it. But I want you to read through it 3 different times with different things you're looking for each time, and I want you to hash it. Not because I want you to be hurtful to anyone. You're not trying to be critical. You're just trying to whatever you think. They're going to make the choice if they're going to use your information or not. And it's not going to be graded upon what you graded. I'm going to be looking at it though, did you really make the effort to help the person? Your lab score is going to be based upon the combination of, did you have a reasonable rough draft to work with, and how much effort did you make according to really getting after their paper so you can help them write a better paper. And like all things, right? As this is nearing the very, very end of our course, it's these last few things and the efforts you make here that are going to make or break that difference of a couple percentage points either way, both in terms of your actual score and for me to give the opportunity. I'm not going to knock you backward, but am I going to look at when you're a couple percent points shy of your A- versus a B+, or your B- versus a C+, or whatever it might be? I'm going to be looking at that. How did you do those last couple weeks? How are your efforts? That's going to be the potential to bump you. I will not knock you. Whatever your grade is, I will tell you what that grade should be when I see that score, but I'm also going to tell you if I gave you a little boost because of the expected, the going beyond expectations. There has to be always something for going beyond expectations. That said, so just finish that paper, rough draft, and review that paper. Of course, your final posts for this week, I'm going to be responding to everybody tomorrow on Saturday for these posts, so you can make any follow-ups for that, as well as following up with your classmates. And then next week we'll have our third exam and finishing up whatever you have left with your paper, your final post, which won't be overly difficult, and of course your project to take it all the way through. You'll have a good week and a good couple weeks to finish all of that if you need it. Okay. That being said, let me know if you have questions, if you have concerns, you have problems. We have to be doing that. I say it all the time, and I keep saying it again. No one succeeds alone. Whenever you need help, seek it. Okay, maybe it's not me. I'm just going to assume that if I don't hear from you, you're doing fine. That's my assumption. You're fine. Why would I think anything else, right? I'm assuming the best. I'm hoping for the best. But if it's not going great, let me know. Okay. If you want to let me know it's going great, that's cool too. Take care. Talk to you again soon.